So now we're going to shift into our first batch of lightning talks. And so we will have 7 talks broadly on topics of AI and natural language processing.
Hi, my name is Lin Jun, and today I'm going to talk about bridging the gap of human AI communication for visual language navigation. The motivation behind this work is that we want to make our AI assistants more helpful and safe by aligning the AI agents with human on how to perceive and describe the world. The underlying mechanism is that if AI agents possess human-like cognitive capabilities, they can imitate human behavior more robustly. To make them think like humans, it's also important to evaluate whether they can think like humans. And the evaluation step is difficult for the black box models. We studied the problem of grounded instruction generation. The task is that, like, given the you are in a 3D photorealistic environment, and the agent is asked to, given a path, to generate language navigation instructions to guide humans. And we study how to generate better instructions by reasoning pragmatically, and also how to evaluate AI models on cognitive capabilities essential for human-level pragmatic communication. This image shows the overview of our model. The first 2 robots they make up for our bounded pragmatic speaker. The first agent is a base speaker, which generates a set of relevant candidate instructions for a path, and we fine-tuned from some large language models as well as trained from STM. The middle robot is a theory-of-mind listener, which simulates how humans would follow the instructions, and then it selects the instruction with the simulated path most similar to the intended path. We found that using ensemble is better than using single agent. And then human listener would follow the selected instruction in the environment, and we evaluate how well they can reach the intended destination. We also introduce cognitive evaluation for the task, inspired that humans are bounded pragmatic speakers. We evaluate 2 cognitive capabilities for the agents. One is search capability, which evaluates whether they can generate relevant instructions. The second is theory-of-mind capabilities, which evaluate whether they can simulate how human interprets the instructions. So we equipped the agent with search capability, with human-level search capability and human-level theory-of-mind capability, respectively, and see which one has more room of improvement. Our experimental result shows that the agents generally have good search capability, but poor theory-of-mind capabilities, because when they're equipped with human-level search, it just increases a bit of the performance. But if we're equipped with human-level theory-of-mind capabilities, the performance improves a lot. And when we use ensemble agents as theory-of-mind listeners, we are able to improve the performance of the base speaker models and shrink the gap with humans by 36%. In conclusion, to develop safe and helpful AI requires quantifying the gaps between an AI agent and human, and augmenting the speaker models with theory-of-mind capability helps, and also have some room of improvement. And for information, please check out a paper with my amazing collaborators, Kang and Hao. Thank you.
Thank you, Lingjun. Okay, next up is Yaoting. You want to head up, and I'll get you set up.
Hi everyone, I'm Yuting, and this is my work with my advisor Joel, but we had some problem coming at the last minute, so somehow I didn't check the latest slides very carefully. So yeah, this will sound more like an NLP talk than an HCIL talk, but because this is my first HCIL talk, please, please be tolerant to me. Okay, so this project is about like helping interdisciplinary scholars to like just search for different like terms from different communities, like when they like in this case, like so for Joel, he's very familiar with psychology, and he wants to like know something about management. He knows a little bit, but like has not found what he wants. So like this is the approach that caught his attention. Like this is some sort of NLP models. So this is like, there are like two maps. So one is for psychology, the other is for management. And he wants to go from psychology to management. So I say he wants to approach management. So this approach, I have NLP background. I will explain this maybe a little bit of jargon, so it should be okay. Yeah. So this is like when we want to align to the semantic space of the two languages, we kind of assume that they are describing the same thing. So they must be aligned in a way that they maximizes the overlap, because like otherwise it would not be the language. Like there should be like the two languages in the same world should be like should be like mostly the same, right? Otherwise it's not the same world. So this is like for NLP, this is like we just kind of rotate this distribution so that it got aligned, so that we can know which one is closer to which one in this aligned map. So Joel proposed to do a cross-lingual mapping like this across research communities. But as like with my NLP background, I saw some problem, but I'm not sure. So this is our proof of concept. We are mapping psychology to management, and so we use this NLP techniques, which is fine in my opinion. And it turns out that examples overlaps with substitutes. Well, not totally overlap, but very close. And the interesting thing is that there are two examples in this figure. One's from psychology, one's from management, but they are not aligned in this supposed to be aligned map. So these are some examples of why Joel thinks substitutes is relevant. He just said interesting, not relevant, but I'm confused. So I try to come up with a solution that makes it relevant. So I said, like, substitutes is like examples of each other. Sorry, I know this is not a good presentation at all because it is not prepared in my sense. We don't have, like, I don't think the model is right. I don't think, like, everything does not seem to be right for me. And I have some prototype which is apparently not right. And I didn't even get to add a link. Okay. So yeah, this is the end of my talk.
Thank you.
Please, if you have any questions or comments, please let me know and let Joel know. Thank you.
Thank you. Okay, Tracy, you want to come up? Oh, you're already here. Yeah. Look at that. It's amazing. Okay, go ahead.
So which microphone do I have? This one or?
You're fine. Just talk in there unless you want.
Okay, let me check if I can play my slides. Okay. Hi everyone, I'm Tracy. Today I'm going to introduce Tutor AI, a collaborative project with UMD and Adobe. Have you watched online videos to learn a life skill, like how to fix a flat tire or how to cook a dish? If so, you may have experienced pain points of following instructional videos, as the time player does not have an overview of steps. And if you want to find exact moment, you need to scrub the timeline, which is imprecise and tedious. Here is where mixed media tutorials come in handy. Mixed media tutorials combine video formats with other media formats like images, text, and diagrams to make the content more browsable. YouTube also has its own mixed media format, YouTube chapters. Each YouTube chapter has a text description along with timestamps, so it allows users to easily find the moment in a video. Researchers have also proposed more advanced mixed media tutorials. For example, for a beef stack recipe video, besides steps, we can also extract all those object information. So when consumers click on those buttons, they will see images of the ingredients. And besides the sequential orders, we can also build dependencies among different steps. So if there are 2 people in the kitchen, you can separate tasks. However, creating such mixed media tutorials is challenging. First, manual creation is tedious and time-consuming. Imagine you need to summarize each step and extract all the object information. Even if we want to use AI to help with the creation process, there are also several challenges. One is that such tutorials have a lot of components, like objects, steps, and dependencies. And it also involves content across different modalities. So how can we choose and assemble different machine learning methods together to create such tutorials? Besides, AI is imperfect. How can we guide creators to refine those AI generated results? Here are our contributions. First, we evaluated relevant machine learning methods to generate mixed media tutorials. And we also come up with principles to select and assemble different machine learning methods together. We also developed an interactive prototype to guide creators to refine AI generated results. And finally, we conduct user studies to evaluate our UI and also the quality of created mixed media tutorials. So here is our demo. The first step is to identify steps of the tutorial. AI has already provided steps, and creators can refine the results, like add a new step or delete steps. And after that, they can select thumbnails recommended by AI. And then they associate different objects to each step. And they can also select images for some objects so that the consumers will have a more intuitive idea. And finally, they can build dependencies among different steps. This is the final tutorial look like. It has an overview, and also if you hover on those buttons, you're going to see images. And finally, we conducted 2 rounds of user studies. In the general user study, we recruited users who regularly watch YouTube tutorial videos, and we asked them to create a mixed media tutorial for berry cake and chair assembly in our tool. And in the second round, we recruited YouTubers who have created instructional videos, and we asked them to create a tutorial based on their own videos. And here is the evaluation. We asked them to rate the usability of editing features of Tutor AI, and we can see that the ratings are pretty high, mostly 4 and 5. We also compare the quality of our tutorial versus YouTube chapters, and we can see that even before editing, the AI generated results are higher than YouTube chapters. Besides, we also have more components, like object information and dependencies. And this is after editing, and all those users and creators rate that our components will benefit consumers more than YouTube chapters. Currently, our work is under review, and I'd like to thank my advisor, Professor Liao Chengliu, and our collaborators at Adobe. And thank you.
Our next talk is, we have a few talks today that folks had to go to internships or otherwise couldn't be here, and they pre-recorded. So our next talk is from Nemo Hoke, and it's augmenting human AI co-writing with information visualization. So let me get this up and playing.
Hello everyone, I'm Naimul, a PhD candidate at University of Maryland. I'm glad to be here and present my work on human AI co-writing. Let's start by understanding the history of human AI co-writing a little bit. We have been using computational support for writing for a long time now. Even before I started using a computer, Microsoft Word 97 had the feature of automatic grammar check. Nowadays, we use Grammarly regularly in all sorts of writing. And of course, generative AI like ChatGPT has rapidly changed the human AI co-writing paradigm. While these are exciting applications, many creative writing tasks require writers to design complex and abstract narrative components such as narrative structures, characterization, and dialogue. We still do not know how to best apply AI to such complex creative writing tasks. In this talk, I'll demonstrate how NLP and interactive visualization can be combined to help writers design complex narrative components. I'll present two case studies, one on mitigating social biases in fiction writing and one on the design of characterization. I'll conclude by outlining the broader impact my work on human AI co-writing. The first system I want to show is called Dramat-Based Personae or DBP, a tool for writers to interactively evaluate the presence of social identities in a story. The central component of DBP is a text editor. A user can write on the editor or paste written text into the editor. As the user writes in the editor, the characters in the story are automatically detected in the system. Here's an example use case of DBP with a story. A user can merge different names of the same character together. For example, Aurora and Princess are the same character. We can drag Princess to Aurora and drop to merge them together. Each character in this panel has a drop-down named Demographics. Using this drop-down, a user can add any social identities to the characters. And what that enables us is to visualize the presence of the social identities in a timeline. In this example, we are seeing how three identities appear in the movie The Amazing Spider-Man 2. DBP can do a whole lot of other things, but I want to move to the next system. This one is called Portrayal. This tool was designed to capture nuanced character traits and help writers design dynamic and engaging characters. I'm not going into the details of the design of the tool, but let's see some new insights and results that emerged from the user study with writers. A participant analyzed a short story written by her. For example, she wanted to see how the sentiment of the characters had changed in the story. She was reassured to see the change matched her intended arc for the lead character. The lead character was sad at the beginning and then slowly became joyful and finally became sad again. Another participant investigated the adjectives and actions in the interface. He found that Bozena, an important character, had a small number of adjectives and actions. He decided that the character has more room for development. What makes Portrayal really powerful is that a writer can use multiple character traits together to identify discrepancies between intended and written text. All the views are tightly coupled with the text on the right. I now want to discuss some of the impact of our work and future direction. First, our work promotes human-centered AI. The visualization and interaction help writers take informed decisions. Writers were able to use analytics support without any algorithmic expertise. With that, there are opportunities to study how to visually represent other narrative components such as narrative structures and events. There are also several open problems in this domain for NLP, like book length co-reference resolution. Beyond these applications, I am most excited about bridging generative AI with analytics. What could be the benefit of analyzing contents generated by an AI? This paradigm has the potential to resolve some of the known problems of generative AI. Analytics can explain the reason behind generated text, thus improving interpretability and trust in the process. Finally, it can also ensure that the generated text is bias-free. With that, I want to thank my collaborators and thank the audience. Thank you.
Okay, so for the next talk, Joel is going to pinch hit for one of his students who wasn't able to be here today. So,
all right. Hi, everybody. I'm Joel. Jason is in the air right now to Seattle for his internship at Microsoft. So I'm going to present this work, really fun project that's actually about generative AI. So nice sequencing. This project is motivated by the fact that cross-domain analogies have strong creative potential. Examples you may not know of. Printing press was invented by analogy to the wine press. Here we have GIFs showing how the insight from a cardboard box twisting inspired the core principle of wing warping that enabled the Wright brothers to achieve human flight. These are amazing insights, but are difficult for people to retrieve or generate in terms of cross-domain analogies. We've got study after study showing how people sort of get fixated. They have trouble thinking of ideas outside their domain. And the thing we're curious about is how we might computationally support this process, help people to sort of retrieve and generate cross-domain analogies more reliably. In this particular project, we're curious about large language models, a subspecies of generative AI, to augment cross-domain analogical creativity. Not to do it themselves, but to help people. Right? Why do we think this? We've got some pretty good evidence that GPT-3 and other models like it do pretty well on SAT-like analogy word problems, like king is to queen, as man is to woman. We also have some interesting proof of concept demos of using models like GPT-3 to generate or explain complex verbal analogies. For example, you may be familiar with the analogy between water flow and heat transfer. We feed that into GPT-3, out comes plausible explanations of correspondences we would expect between water and heat, the thing flowing, pipes corresponding to conductors, and so on. This is cool, but what's missing for us is a systematic evaluation. How often can we do this? How reliable is it? And in particular, we are not interested in correctness. We're interested in how does this help people? We don't care if GPT-3 can generate analogies. We care if this helps people. So that's what we did. We designed a in-context learning prompt for GPT-3. We have a good sense of how often it generates cross-domain analogies. And then we ran a study with people to actually use this in a creative task and get a sense of its impact. Okay, so very quickly, this is the structure of the prompt. If you're familiar with GPT-3 or ChatGPT, you feed in like a chunk of text and then it completes it. The instructions are, please generate a situation that has a very different stakeholder and context, but very similar goal or obstacle as the prompt, as the input. Here we have an example where we have a stakeholder of owners of a travel agency during the pandemic, wanting to reopen again. And their goal is to reopen the traveling business. The obstacle is they can't find enough employees because people have left the travel industry. So we feed this into GPT-3, and the rationale for this breakdown is we get sort of a different domain by chaining the stakeholder and context, and then we get a similar goal or obstacle that gives us analogical similarity. Here's an example output from GPT-3. Stakeholder is a theater troupe, so we got a different domain. Their last performance was met with peer reviews. Their goal is to turn their fortunes around, and their obstacle is the leading actress has left the troupe. So here we have different domain, travel versus theater, but we have shared kind of goal obstacle, like a key resource is leaving. This is an example. We generated 480 of these across 6 design problems, and we had somebody judge them. About 70% of the time, the mapping makes sense. We could imagine this being useful in a creative task. When we actually did it, we got 113 participants to use 108 of these analogies to try to reformulate a creative problem. Key results, which you can see at the poster, we got high helpfulness ratings for the analogies for the task, about 4 out of 5 on a 4 to 5 scale, 1 to 5 scale. And we got to see a content analysis where we see we got frequent stimulation of problem reformulation from the analogies, about 80% of the time. So we think this gives us some systematic evidence that we can use large language models to augment analogical creativity. We have some future directions in terms of improving the depth of insight in the analogies. They're kind of shallow. They can be useful, but they're kind of shallow. So we're interested in how we can augment this. Eager to talk about this. And with that, I'll invite you to come talk to us at our poster. I will be there. There's a last thing to mention is that this paper was awarded an honorable mention at Creativity and Cognition. We will present it next month. scan the QR code to read the preprint, and contact Jason if you have any questions, or talk to me. Thanks.
Thank you, Joel. So as a reminder, one of our birds of a feather tables for lunch, I don't know if it's full yet, is around generative AI. So this is obviously a hot topic, but we're going to stick with analogs. Arvind, do you want to come down?
Hello, everyone. So I'm Arvind Srinivasan, here to present my thesis work advised by Dr. Joel Chan called Analogy Lead. It's a system for improving the selection of analogical inspirations. So analogies have always played a crucial role in fostering innovation. Cross-domain analogies in particular have been a major contributor in transferring inspiration from like one domain to make breakthroughs in another. For instance, the guy you see in this picture, like he is Jorge Oron. He's a car mechanic from Argentina who actually, while watching a YouTube video, saw a potential for using an old trick to uncork a wine bottle. Which actually worked like you insert a plastic bag, inflate it, and then pull the bag along with the bottle, so along with the cork to get it out safely. So he repurposed that understanding to create this device for easing childbirths. It's really interesting, right? And the thing is, like, he's a car mechanic, and he basically created innovation that revolutionized obstetrics. So that's the power of cross-domain analogies. So, however, such cases of serendipity are like too few and far in between. So it's like they are hard to engineer. Not to mention that identifying an analogy is not the only hurdle that one will need to cross, because there are chances where identified analogies can actually be rejected due to premature rejection or design fixation. So this guy you see over here, he's the famous guy who invented the pineapple pizza topping. So just think that you are this person for a moment. If you had these thoughts, like just thinking that pineapple on pizza will never work, and Margherita is the king of pizzas, would you have designed this? Would have thought of just putting pineapple on pizza? So that is an example of premature rejection and design fixation. So past studies have shown, like the Dunker and Candle problem here, have shown that by grouping or rearranging the existing problem elements in a different ways, you can actually instigate people to think of a problem in a different way, as said by Joel in the previous talk as reframing. So this was also like repeated in other kind of experiments, where they, instead of focusing on like physical objects, they tried to repeat the same experiment with the text, and it seemed this was common across all kind of representational modalities. So what we got from this is that representational change can help in problem solving. So we thought, can this kind of representational change be useful for mitigating premature rejection of analogical leads, and can we design a system that wraps around this concept? So our system incorporated two aspects. The first one was chunking. So assume that your problem is like to design a baby carrier that can be used in harsh climates to protect babies from elements that's while still allowing them to be carried. So we break them down into four components. In this case, the stakeholder who's in focus is babies, and in the context of harsh climates, their goal is to be protected from the elements, and the obstacle is need to be carried. Quite simple, right? So after breaking them down, we also provide a system that uses large language models, and the prompt is basically similar to what was discussed in the previous task, and we use that to generate questions. For example, let me take you to this example. So you have the problem, which is broken down into components, and the analogy, which is also generated using large language models. In this case is soldiers in a war-torn territory. They may need cover from aerial attacks, and the kind of obstacle is that the ground launch missile for defense. So that's kind of like a solution here. So yeah, so as you can see, there's this common context of the relationship between harsh environments, right? So there's harsh climates here, there's harsh environments there. So this is the analogy that has been generated. So as you can see, you have the ability to select individual words that you feel like would help you come up with interesting questions. So in this case, I'm just selecting territory, covered, aerial, missile, defense, because these seem to be interesting nouns that could be combined with this. Let's see. So this was a question that we got from an actual question that we got from the generation. So this question says, how can a missile like defense system offer territorial cover for babies in harsh climates? So looking at the territorial cover, right, you can think of a lot of things like maybe there is, you can have a weather sensor that senses the weather and changes the a baby carrier to adapt in particular ways. As you can see, like this kind of questions, these are like guiding questions that help you guide towards a particular way of applying something, an analogy to solve a problem. So we evaluated the study with within subjects, and we got 4 times less rejections, 12 times less decisions, and the revision of decisions, and almost 0.64 times longer processing time. So that's about it. So if you want to learn more about it, so please join me around at the poster. Thank you.
Thank you, Arvind. Okay, our last in the AI subcluster, we're going to have Connor. Should Connor want to come up?
Hi, everyone. Today I'm going to be talking about our work about the impact of explanations and fairness in human AI decision-making with respect to protected versus proxy features. This is joint work with my collaborators, Navita, Tin, and Hal. So it's well known that leaving a biased AI system to make important decisions alone can lead to harmful outcomes. There's hope that human AI teams can produce fairer outcomes, especially when humans are provided explanations of AI predictions. However, it's unclear whether explanations can help humans calibrate their reliance in a model that's exhibiting biases that stem from proxy features. So a protected feature would be something like gender or race, and then a proxy feature would be something like the university you went to, your zip code, that correlates with a protected feature. So to address, we ask questions such as, how does human AI decision-making fairness change when model biases stem from these protected versus proxy features, and when humans are told about model biases directly, or about the correlation between protected and proxy features. So to address these questions, we conducted a human study where humans are asked to complete a decision-making task with the help of a model that they don't know is biased. The study is roughly split into 2 halves. They're asked to do the task 2 times, and at first when they're doing the task, they're not primed to consider fairness at all when they're making decisions. In the second half, they have more information. So when they're doing the task, which is going to be loan outcome prediction in our case, they're shown a graphic like this one that includes an applicant profile with information like what is the amount of the loan that they're asking for, an AI prediction on whether the applicant will complete or be late on the loan, and a feature importance score based on the AI model. So in this example, we included the protected feature of binary gender. And instead of this, some participants instead saw a proxy feature, in this case, university. So here, the AI can still be indirectly biased against women by penalizing applicants from all women's colleges, even if it doesn't have direct access to the gender feature. So like I mentioned, there's kind of these 2 halves to this study, and in between, participants are given disclosures about the model and training data. So they may be told about the level of bias in the model. In this case, we're looking at demographic parity, which is a comparison between the rate of predicting that men versus women will complete a loan on time, and then correlation disclosures about the correlation between university and gender. So we find that before any disclosures, human AI demographic parity is only significantly better than the parity of the AI model alone in the protected conditions. So when you're told about gender specifically, this is kind of an easier setting because if you're like seeing the red bar next to female, that's sort of like a pretty obvious signal to the participant, even if you're not telling them anything about fairness or model bias. Yeah, and then between conditions, after they're given more information, the gender parity significantly improves in all conditions. However, in the case of proxy features, participants can only reasonably intervene to improve gender parity for applicants who went to women's colleges, since they won't actually know the gender information for the people who went to co-ed schools. So instead, if you look at the demographic parity between people who went to women's colleges and didn't, now the improvement between the two phases is only significant when you give people explicit information about the correlation between the different universities and gender. So overall, we conclude that explanations can be helpful to humans in identifying fairness concerns when biases stem from a protected feature, but can be insufficient when model biases stem from a proxy feature. Correlation disclosures significantly improves parity in the cases that are most affected by this proxy feature bias. In this experiment, we found that simple input influence explanations and disclosures are effective in this case with a single proxy or protected feature, but more work is needed to design appropriate interventions for more complex biases. Thank you for your attention.
Thanks, Connor. So we're going to pause again for more questions. If you have questions on any of the first 7 talks, except maybe the video, which I don't know if any of Nimul's collaborators are here who could answer a question if there was one. Oh, don't run away, Connor. Come. There's a question for you.
My question was that when you did the study, did you also include the ethnicity of the group that you were studying, and also like the culture of their birth or the country?
Yeah. No, in this study, we just wanted to do a simple, there's a single protected feature, there's a single proxy feature, but with more like interactions with intersectional groups. I think this would be like more complex case for the like explanations and the disclosures that would be needed in order for these interventions to be helpful to people. So that would be definitely an interesting avenue for future work. Thank you.
This is good. I'm getting all my steps in for the day. Whew. Okay, time to breathe heavily. Okay.
So I have a question for Jason's pinch hitter. So for his project, he's talking about like the analogy generation, and I want to know if that can be extrapolated cross-culturally for ESOL work. So basically making analogies instead of trying to use direct translation work, because often they're coming from a different context into a different context in a different language. So can you use that to like kind of blow it out and say, while you're learning this language, you're learning this concept, we're trying to teach you content in language. Can that model be used to make analogies that way to kind of strengthen and do a more holistic language learning process?
I think so.
Okay.
I wouldn't use it directly with the student. Like I would imagine this as a instructional support tool, as like helping develop more mapping, personalized materials, and that kind of thing. I'm worried about sort of like there's no way to check correctness if you don't know the target language. But if you put in a kind of instructional support loop, I think it could be helpful.
Other questions? We have time for 1 or 2 more before we move on to our data viz themed talks. I'll check online to make sure nobody's dropped a question there that I missed.
Oh, we got no questions online.
Oh, you just checked? No. The Zoomies, as I like to call them, are quiet today. Okay, well, we can move on. And again, there will be more opportunities for questions. So next up, we do have another video that hopefully I will be able to get loaded without any issues. So we have 6 data viz team talks. We'll do 3, and then we will, and then we'll take a break, and then we'll do the other 3.
I am Songbok Shen.
The presenter of the work, DrillVis, Adaptive Visualization Dashboards for Supporting Varying Expertise and Support. This work was done in collaboration with INYAPNA and with the United States Department of Agriculture. This research idea started with the possibility of presenting a visualization where the visualization can be used by both people with little knowledge and a lot of expert knowledge about a topic. The assumption behind this idea was that people with little knowledge would want simple and abstracted information, whereas people with expert knowledge would want more detailed information so that they could use to assume the causalities about the abstracted information. We thought that this was useful because having a visualization that can be used by both experts and those with little knowledge about the topic could facilitate the communication between them. In doing this, we developed a visualization technique called DrillVis to first author and then present a user-driven hierarchy of data sets in a dashboard format. Now, DrillVis is composed of two modes. First, the author, and second, the reader mode. In the author mode, the author can create the hierarchy by merging a set of baseline charts iteratively using predefined relations. In the reader mode, the reader can view the hierarchy of visualizations authored by the user. The reader can drill down the details by clicking the charts. Now here is how DrillVis looks like, and here is the reader mode. The chart here is the author mode. First, the user can update charts from the dataset upon their interest. The charts can be filtered based on the user's conditions. Then, the user can merge the charts based on the set of instructions provided by the tool. These are add, subtract, scatter, merge based on one or two axes, and hide. And the trivia on the right shows the overview about the user-driven hierarchy of the charts. And you can also enlarge or expand each of the visualizations. Now here is the reader mode. In the reader mode, the charts you see are at the top of the hierarchy. When you click the visualization, you can see the level below the top of the hierarchy, and you can see what it is made of. You can continuously click the visualization until it reaches the leaf of the hierarchy. Note that the trivia is highlighted when the user hovers to the visualization of their interest. For our future work, we aim to conduct our user study with people from USDA, first to explore how people with different levels of expertise use the reader mode using farm data. And the questions we're interested are how often they drill down or what information was most memorable. And secondly, we also try to explore expected methods for authoring the dashboard. And here we could ask questions such as what tool do users use the most, or what information was also most usable. I'm happy to talk more about the research. If you're interested, please email me on the email below. I was Song Bok. Thank you very much.
I think. Okay, hello, I'm Hami Song, a PhD student in computer science. I'm excited to present our research, intent techniques and components of unified analysis of interaction authoring tasks in data visualization. There's been a growing interest in facilitating easy interaction authoring. However, we discovered that there is the need for theories and models that describe the tasks of interaction authoring of data visualization. In addition, the current literature primarily focuses on the analysis and communication aspects rather than how interactivity is composed. Let me illustrate hypothetical scenarios to provide a better understanding of how designers might design the interactions of data visualization and the goal of research. The given context is as follows. A designer aims to add interactivity into a static multi-line graph. At the lowest level, the designer could utilize a programming language to create a graphs path. At a higher level, they might choose a template using GUI. At the highest level, the designer could input their intent, allowing the system to generate techniques and implementations based on selected recommendations. The nature of multifaceted interactivity motivated us to bridge the existing gap by providing a unified framework that describes interaction, authoring tasks, and multi-levels of abstraction. In terms of our research approach, we first gathered 47 real-world examples. Then 3 researchers conducted cross-checking analysis processes so that we analyzed 592 interaction units derived from these examples. Finally, we classified them especially into the intent and components level of abstraction. Our contributions are, we defined 9 types of authoring intent and 3 categories of components. Eventually, we contribute a unified framework describing interaction authoring tasks and multi-levels of abstraction. This teacher image shows the summary of the categories in our unified analysis of the interaction design space. First of all, authoring intent means what a designer wants to achieve. We defined 9 intent, for example, select, steer, etc., based on the 3 types of changes. Techniques are methods that designers achieve an intent. For example, one of the intents called select can be executed through several different techniques, such as point select, which is about selecting a single item, and multi-select, which is about selecting items within a specific pixel range. Components serve as the building blocks for implementing interaction designs in visualizations. In this case, they handle the details of what input and outputs are involved in that process. Based on the categories, we contribute a unified framework describing how categories work together. For example, a narrative visualization on the right side, we can interpret that its authoring intent is a steer. In terms of techniques, designers wanted to design interactions that enable their users to navigate different scene or section through the interactions, such as scrolling or clicking on UI. In this process, the components reference current scene updates, changing the currently visible view. To sum up, to bridge the gap between existing literature and the requirement of studying how interactivity is constructed, we define 3 levels of abstraction for interaction authoring and related categories. We also contribute a unified framework of the task space of interaction authoring across the 3 levels of abstraction. This paper is under review, and then I truly appreciate the remarkable efforts made by the collaborator and my advisor. Thank you for listening.
Thank you. Okay, we're gonna have Kazi come back up and hopefully get the right slides open. Okay. So that is the one that was up. Wait, let's refresh, because that does not look like the right one. Okay, today, haha. Okay, that's the right one?
Yeah.
Great.
Thank you.
You are welcome.
So hello everyone, I'm Zinat again. So I'm here today to present my work, which was done under Professor Liu Jicheng Liu. The title of the work is a comparative evaluation of visual summarization technique for event sequences. This work has been accepted to the 25th Eurovis conference. So over the past 2 decades, more than 20 event sequence visualization tools have been published. These techniques visualize the summary structure in different ways. The same dataset can be visualized as a graph, a set of linear sequences, or a tree structure by different techniques. Even for the same summary structure, techniques may use different mining algorithms or different granularity. For example, both the left and right figure here have the tree structure, but the contents are different. The left figure has a finer granularity and the right figure has a coarser granularity. However, we have little understanding on how these tools compare to each other and what are their strengths and weaknesses. To date, there has been no systematic evaluation available to compare event sequence visualization techniques. Therefore, practitioners have no guidance for choosing a technique for their data and analytic needs. Therefore, to address this gap, we re-implemented and compared 3 event sequence visualization techniques through a crowdsourced evaluation study. Now, we present the techniques that we use in our study. We include 3 types of summary structures: linear sequences, directed acyclic graphs, and tree. We choose sequence synopsis, core flow, and sentence tree as the representative techniques for the summary structures. To eliminate the potential confounding effects, we implemented a minimalistic and consistent design for these techniques. You can see like here, sequence synopsis, sentence tree, and core flow presented here are our own implementations. We selected 6 datasets from different areas of application. However, no established benchmark ground truth on these datasets are instantly available. Therefore, we curated associated insight from publications and supplemental videos. We identified 3 insights per datasets. Our curated insights led to 3 high-level analytic tasks: common pattern identification, clustering, and anomaly detection. Let's take a quick look at the variables in our study. We have 3 analytic tasks, 2 datasets per task, 3 insights for each dataset that can be broken down to 6 granularity levels, and we have 3 techniques that we are comparing. Therefore, we have 324 unique combinations. We assign 3 insights for all 3 techniques, or 9 combinations per participant. Therefore, we are left with 36 unique conditions, and we assign 5 participants per condition. So there are 180 total participants in our study. We developed a 3-phase evaluation process to ensure the participants have adequate visual and data literacy. The participants first complete a tutorial and a pre-screening test. Then they proceed to the main experiment if they satisfy the pre-screening criterion. We perform our evaluation based on the following collected data: a Likert scale rating for summary accuracy, time to judge the summary accuracy, and 1 text justification for each technique. The first to help us quantitatively compare the techniques, the text justification makes qualitative analysis possible. From our study, we found that rating and completion time, there is a trade-off. To make it more clear, we can see that for summary accuracy, higher rating is obviously better, and for judgment time, if it takes less time for the human to judge it, then it's better. But we can see here like there is an inverse relation if the rating is higher. For example, sequence synopsis, which has the highest rating for all 3 tasks, it has also the highest judgment time, and core flow, which is the lowest rating, has the lowest judgment time, which is not expected. So balancing summary complexity and accuracy is crucial for all visual summarization technique for event sequences. We also performed open encoding on the collected text justifications. We identified 8 total tag categories with 799 total tags. Our qualitative analysis shows participants emphasize on 2 overarching themes for evaluating the visualizations. The first theme is content, how closely the patterns in the visualization match the insight, and the second theme is interpretability, how easy it is to read the visualization. From our analysis, we find that no perfect visual summarization technique for event sequence data exists. There is still room for improvement in accuracy, computational resources, and interpretability of visual summaries. To summarize, our work makes the following contribution. Experiment design. We designed the first study to comprehensively compare visual summarization techniques. Result analysis. Our analysis offers understanding of technique performance, trade-offs, and areas of improvement. System reimplementation. We reimplemented 3 existing summary techniques that we plan to open source. Thank you.
Let's move on. We have 3 more Viz talks before we break for lunch. We can work up your appetite just a little bit more. So, who do we have up next? Chen, want to head up?
Hello, everyone. My name is Chen, and I'm a PhD student working with Professor Zhicheng Liu at Department of Computer Science. Today I'm going to present the state-of-the-art survey in creating visualization corpora for automated data and video data analysis, which will be appearing in this year's Eurovis conference. So recent advances in the automated chart analysis has enabled more effective chart retrieval, creation, interpretation, and reasoning. And behind each of the techniques, there will be a chart corpora on which the authors train or evaluate their model. An example would be the reverse engineering visualization paper from Poco and Here, where they manually collected more than 4K charts from 3 different sources and annotate the bounding boxes, contents, and the rows for each text element. And then they use a corpus to evaluate their model, especially for the text localization and recognition pipeline. However, we have observed there is actually little research on the common practice to create good chart corpora. And also there's few discussion over the potential gaps in existing corpus-based research. So in general, this phenomenon has made it very hard to compare different approaches, to measure scientific advances and to identify underexplored research problems. So to fill this gap, we have surveyed 56 publications in the automatic chart analysis research from the field of AI, NLP, HCIL, and visualization. We first examined the goal, method, and the output of each paper to create a why, how, what taxonomy. And based on this taxonomy, we further discussed in detail 5 key corpus properties. They are format, scope, collection method, annotation, and diversity. So to give more details for format, we have categorized the chart formats in each paper and then compared the pros and cons of 3 types: bitmaps, vertex, graphics, and programs. We also discussed the chart selection process regarding the number of chart types considered in each paper, and we discussed how it is influenced by the task goal and method. We further identified and discussed 4 main collection methods for all the charts. For the annotations, we summarized commonly seen annotations as shown in this table, and we also identified 4 main annotation methods that is used by the researchers. And last but not least, we have abstract researchers' common practices to enhance their the diversity in their chart corpora. And we also discussed why diversity is actually why diversity matters, especially for the generality of the models. Based on this survey, we further discussed the following 6 research opportunities, which are chart topologies being not expressive enough, chart similarity being not ideal for retrieval, and true source agnostic system development, more smart design auto generation from data sets, and how to measure diversity quantitatively, and the last, how to understand interactions animation in the existing charts. To be specific, sometimes the chart topologies used in the papers are not consistent and they are not expressed enough. For example, in these 2 figures, you can see both of them cannot be described using just one single chart type. They have to be described using composition of 2 different types. How to address this gap, it actually remains open. And the second one is about the tool and source agnostic analysis. This is highly related to the corpus diversity. Here we quote from Lee, etc., the paper called Structure Aware Visualization Retrieval, where they claim their system built upon charts from Plotly cannot handle charts from maybe D3 and Adobe Illustrator. So how to make robust systems that can take inputs from diverse sources and at the same time output consistently is another important research problem. We further noted desired properties and tools for creating benchmark corpora. To be specific, an important direction would be developing human-in-the-loop annotation system to enable multi-level fine-grained labels for the charts that include more meaningful semantic for minimal semantic informations. So let's end the presentation here at the opportunity page, and I would like to thank you, my advisor Leo, for his guidance, and I'm happy to take any questions. Thank you.
Thank you, Chen. Next up, we have making sense of waiting time activities. Jian, is it just going to be you?
Hi, everyone. I'm Jian Zheng. I'm presenting our study about waiting time activities. Each day, we all spend a lot of time waiting for something. So I just wait for my turn to give this presentation. And have you ever paid attention to how you spend your waiting time? Maybe using social media, watching TikTok, or checking emails. HCIL researchers have developed some tools to encourage people to be more productive while waiting, such as to learn vocabulary of a foreign language. However, little is known about how people naturally spend their waiting time. And without such a baseline, we cannot evaluate how much productivity could be improved using such a tool. Therefore, we ask two research questions. First is, what do people do while waiting? The second is, how do situational factors affect people's waiting time activities? We conducted an experience sampling method study, or ESM study. In ESM studies, researchers send out brief surveys several times throughout the day to capture the participants' certain aspects of experience right on the moment or immediately afterward. We recruited 18 participants and asked them to report their waiting time activities whenever they found themselves waiting for something, at least 3 times a day for 2 weeks. And the data was collected through both self-report and app usage logging. With the ESM tool developed by me, participants report their activity, duration, time, and location of each waiting they have. And in the app usage logging data, the starting time, duration, and application name of each active phone and computer app were recorded. Following previous ESM studies, we coded all the activities into leisure, maintenance, and productive activities. Leisure activities include using social media, watching video, or listening to music. There are some things people do just for fun. And maintenance activity include like sleeping, eating, taking personal care, or doing housework. That's something that people have to do almost every day to survive, but not directly associated with payment. And productive activities include work and study. They lead to either payment or self-growth. Yeah. According to American Time Use Survey, generally people spend their daily awake time equally among the 3 categories. But our data reveal that while waiting, people spend about 60% of their waiting time on leisure activities, 20% on maintenance, and another 20% on productive activities. Compared with the self-report data, our app usage logging data reveals that while waiting on phones, people are even more likely to do leisure activities. And they're more likely to do productive activities while waiting on computers. And if so, those interventions deployed on users' phones should have a different baseline from those deployed on users' computers. Previous studies almost focused on waiting at workplaces. We found that more than half of all the waiting actually happened at home. And even though leisure activity took the majority of waiting time across all locations, we can find there's an association between home and maintenance, public places and leisure activities, and between workplaces and productive activities. Throughout the day, there are 2 peaks of waiting time, one around 11, the other around 18 o'clock. And the productivity while waiting clustered from 11 to 20 o'clock. And so waiting time activities depend on the situational factors. If so, it may not be a good idea to always persuade people to be productive while waiting regardless of the situation. In some cases, allowing people to relax to have some fun may be a better choice. And to sum up, while waiting, people spontaneously spend most of their time on leisure activities, and it depends on the situational factors. This result can serve as the baseline for future interventions on people's waiting time activities. Thank you for listening. I'm happy to answer any questions.
Thank you. Okay, we have one more talk. We'll have some questions and then you will be able to eat.
A very pleasant afternoon to all of you. I am Biswaksin Patnaik. I'm a 4th-year computer science PhD student, and I'm advised by Dr. Nicholas Hemquist and Dr. Hua Shipeng. Today, I'll be talking to you about our work, Sense-Making Sans Power Interactive Data Visualization using Color Changing ink. Our decisions in the present-day world are increasingly data-oriented, wherein we interact with a plethora of these devices to interact with information visualizations. These are computational displays that dynamically refresh information as we start interacting with visualizations, which eventually helps with the cognition. At the heart of these displays is electronic computation and power that helps us access information almost anywhere. Well, I do say almost. So what happens when you don't have access to electronic computation and power? In cases such as the print media, like newspaper articles or articles in a journal which is in printed form, or pamphlets, or infographics that you would use in the middle of a trail which has information about the trails or the animals, where you don't have access to computation and power. So the question becomes, can we make interactive visualizations without any electronic computation and power? Can we? Well, yes, we can. We use color changing inks. These are specific inks that change color with respect to when there is an external stimulus. And this is a toy example in which there is no computation or power. This is just a printed paper. And as the user interacts with it, the distribution changes. There is no electronics in it. So how do we do this? There are different kinds of these specific inks, and we study their properties. There are thermochromic inks, which react to heat, and it goes from color to colorless, and that was exactly what we used in the previous example. We also study photochromic inks that change from colorless to color when it reacts with the UV light in the sun. So we study the properties of these inks, and we sort of design a design space. So intuitively, what would happen is if you layer up these inks with regular ink, what would happen is upon interaction, you can select what kind of display it would show. Because upon interaction with the color changing ink, it would either disappear or appear, sort of changing between two states. And that is the very idea behind using interactive data visualizations, behind creating interactive data visualizations with color changing inks without any computation or power. So we show another example here. This is a toy example where a pie chart changes between day and night. There is no computation, no power. This shows crash data of vehicles in day versus night. And in the video, we show this by emulating it in a controlled lab setting by using a UV lamp. But rest assured, it's going to work the same when you leave it out. So during the day, it has one form. At night, it changes to a different one. This is another example. This is a data physicalization model of the Zion National Park. It's a 3D printed model which shows the topography of the park and the animals that are found at different times, specifically at day and night. So what happens here is during the day, a blue tint appears on the animals that are seen during the day. And when it changes to night, a blue tint disappears, sort of fades away, and you see a blue tint on the animals that are seen during the night. We emulate this with a UV lamp and a heat gun in a controlled lab setting. But when you leave it outside, the UV from the sun's light is going to change, bring about a change in colors. So is the heat during the day. So these are some of the ways in which we can make interactive data visualizations without using any kind of electronic computation or power, or in areas where you don't have access to electronic computation and power. Not every visualization needs to be static when it's in printed form. So in summary, we present a framework to design interactive data visualizations without any electronic computation and power. The work has been accepted to IEEE Transactions on Visualization and Computer Graphics, where we have the details of the design framework that has all the ideas which you could use as guidelines to make interactive visualizations without any electronic computation. Thank you.